Welcome to a new episode of Mocap Lab. Did you know that there is a podcast that is supported by the International Society of Biomechanics? It's called Boom, Biomechanics on Our Mind, and it's initiated by two PhD students from the famous Stanford University. In this episode, we will meet them, Hannah O'Day and Melissa Boswell. We will talk about their motivation to start a biomechanics podcast. We will dig around in the history of biomechanics and thereby reveal curious stories. And finally, we will meet Professor Wolfgang Potters and Professor David Camarillo and ask them the question, what is biomechanics? And there is an Easter egg in this episode. Books and pictures of Edward Muybridge's work appear here and there. Can you count how often? Type your counts in the comments below. And don't forget to follow the Boom podcast on your favorite podcast platform. Let's meet Hannah and Melissa.
Welcome to a new episode of Mocap Lab. We are here in our office in Cologne in Germany. And today we have two guests out of the internet from Stanford, out of the US. And they are doing a biomechanics podcast, as we heard, the best biomechanics podcast in the world so far. And
For sure.
Here they are, and we are talking about biomechanics today.
Yeah, welcome Hannah and Melissa from Stanford. Boom, biomechanics on our minds.
Hi, thanks for having us.
Yeah, we're super excited. We usually, are just audio, so it's nice to have this other dimension.
Yeah,
It's a cross-platform thing today.
we're finally showing our faces.
Yeah. People didn't know what we looked like before, so now we can't hide.
Yeah, I thought you were skeletons.
Just simulations, that's what we were.
So when did you start the whole podcast, biomechanics podcast thing? It's great, wonderful. Biomechanics on our minds. When did you start it?
Yeah, we have a lot of fun with it. We're coming up on our second year now, so it's kind of hard to believe it. But it started when I was the student representative for the International Society of Biomechanics, and just wanted to have some platform where it was the knowledge of biomechanics was easily accessible for people all over the world. And then also we talk about things like failures, and we talk about mentoring and leadership and other things in biomechanics. So just kind of spreading the knowledge of biomechanics and research and science.
And what made you go for a podcast in particular? You could have gone for YouTube or videos. Or why did you choose podcast?
Yeah, because we can do it in our pajamas.
Yeah, it was the most comfortable option for the two of us.
That's good. Very good.
No, it's nice because, I don't know, I listen to podcasts while I'm on the go, and so I thought it was just an accessible way to share.
Yeah, I remember when Melissa came to my desk and asked if I'd want to be involved in a podcast, and I was like, what's a podcast? So it's definitely Melissa's ideas. But super exciting, and I love podcasts. Now I listen.
Official podcast of the ISB Society, is that right?
Yeah, so it kind of stemmed from the International Society of Biomechanics, and they help support the podcast and promote it. Well, I promote it because I'm the social media person.
We're really connected.
Yeah. But it's been a nice starting point, a nice and a platform to get the podcast going. And then it's something nice, like when we went to the conference and people know us and we can connect with other students and get new ideas, and that's been really fun too. Yeah. But what about you guys? How did this Mocap Lab start?
Yeah, how did it start?
Yeah, it was an idea of you, Chris. So maybe you
It was my idea,
yeah, you can talk a little bit about that.
Okay, yeah. No, I'm into YouTube for ages. I like YouTube a lot, and I got a lot of knowledge from YouTube. I'm playing guitar, and I think I've seen all the guitar videos over YouTube.
Do you have guitar videos too?
Pardon?
Do you have guitar videos up?
Some, yes, with my band. No, and then I thought, oh, there's nothing about biomechanics so far on YouTube. You could find things here and there, but nothing really structured and really dedicated to biomechanics. And I'm into biomechanics since 2003. I started working at the studying biomechanics at the German Sport University, and as much as I'm into guitars, I'm also into biomechanics. It's two passions that that are competing with each other, and I thought there's nothing about biomechanics so far. Why don't we start something? Because since 2012, I'm having this job at Velamed, planning biomechanical motion capture laboratories. And I've met so many people over the years that have so many exciting stories and do exciting things in their labs. And it's really underrepresented. And so therefore we thought, let's do something about it, meet people, do interviews. About biomechanics and motion capture. This is how we got to it. And
last year I started at Velamed, and so I was a support for Chris, and we were able to buy some cameras and stuff, and we started.
Just went for it.
Yeah, that's awesome.
We always start our podcast off with asking why or how you got started in biomechanics, or what kind of sparked your interest in that field. So we're kind of curious why you became interested in biomechanics.
I studied sports and exercise science, and I was into gymnastics quite a bit. And if you're into gymnastics, and you can't avoid biomechanics.
10.0.
And I've met Peter Brüggemann, and he was actually the professor for biomechanics, but he was also teaching the gymnastics course. And since Peter was doing the gymnastics course, and in the theory there was a lot of biomechanics involved, and I was so amazed and fascinated by the things he taught us. And also I'm very interested in medicine, anatomy, and that's biomechanics. It's about movement, medicine, physics. It combines everything, and it's amazing.
And I'm an engineer.
That explains everything. And how about you?
Yeah.
I feel like, well, for me, I sort of found biomechanics in a roundabout way. I came from biochemistry, actually, in my undergraduate studies. And then I fell in love with neuroscience toward the end of those studies and wanted to do something more translational. So I looked at bioengineering for graduate school, which is where I applied, and then am now in the bioengineering program. And then have always been fascinated by movement and how the brain controls movement, but didn't even know there was a field that addressed that very question. And then sort of linking that with my interest in neurodegenerative diseases got me to where I am today and into studying biomechanics.
So you're coming from the nature science direction.
I started small and then just have gotten bigger.
Cool. And Melissa, and you?
I think my interest started when I was little, and my grandma lost her arm in an accident, and so she had a prosthetic arm. And when I was really little, it was just this really solid plastic arm, and but as technology evolved, she started having, she had a hook, and then the hook could move, and then she had one where it, the fingers could move, and I just found it so fascinating. And then I went to an engineering camp in middle school at the University of Akron, which is where I did my undergrad. So it was a women in engineering camp, and I just loved it. And I love being able to apply engineering to the body and being able to help people, which I think is kind of a cliche. But I feel like it's an engineering with direct application to humans, which is nice.
But it's a great motivation, for sure.
Yeah.
Yeah.
Really like it. So not that your grandmother lost her arm, but it's a nice motivation for doing all this. So
The topic of our mutual episode here is what is biomechanics, and we decided that we kind of dig a bit deeper into the history of biomechanics, and we kind of split the work a bit, and I looked up how motion capture actually started and how technology developed. So there's a long history for biomechanics, as you can see in the script here, and I don't want to bore everybody with repeating all what I found. But yeah, people were always interested in how humans and animals move and what they can gain from the knowledge of that. And obviously it all started with Aristotle and all the ancient philosophers and scientists, up to the Renaissance with Leonardo da Vinci and his ideas on experiments and new innovations. But what really got my interest is Edward Muybridge, and I have this book here. It's a book about his photography work. And Edward Muybridge was actually the first one to really capture motion with a photo camera.
He's here at Stanford for...
Yeah, I think he was at Stanford, yeah. He was kind of like a strange person. I think he was accused for murder at some point. I think he came from England, and he was born in, I wrote it somewhere, 18 something, and he died in 1903, I think. And in between he was accused for murder.
Yeah.
There's some question marks, I think, around.
I think he definitely did do that.
And he got away with it, I think, actually. He was accused, but he wasn't, how do you say that in English? He got away with it. Yeah. Mm-hmm. And he was experimenting with photography a lot, and the experiment most people know is the galloping horse, animal locomotion. I guess you know that one, and I was really fascinated by that. He was appointed by someone who's developing a train, some train stuff, I don't know, and they were interested if horses really have always one foot on the floor, or if they have phases where no foot of the horse touches the ground. And so what he did, I think he did it maybe at Stanford or somewhere in California. He had a racetrack for horses and had a raw horse running along the racetrack, and he had 24 cameras with the same lenses next to each other, and he had little wires going to each camera. And some very special shutter on the cameras, electromagnetic shutter, which allowed for an exposure time of 0.5 seconds, which was very, 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 very good and very, very innovative at that point of time. And when the horses, they were running along that track, they were actually pulling the trigger for each camera themselves by pulling on the wires. And so he was able to actually capture how the horses ran and were galloping. And basically the outcome was that the representation of galloping horses all the years before or all the centuries before was wrong. So he actually captured how it was in reality, and from then on people were referring to that kinematic chain photography of Muybridge.
And it's really ended up being quite a beautiful series of photos. Mm-hmm. There's also another one of a woman jumping over a block. And I really like it because she's wearing this huge, like, Victorian kind of style dress and has like a big headdress, and she's like doing a hop over.
Like all women in that time did.
Yeah. She's in heels, and it was really funny. Yeah.
In this book here, they have a lot of pictures that he did, a lot of photographies, and from all kinds of occasions, from daily living, carrying water, military exercises. And I saw one, I was trying to find it actually, and I couldn't find it.
Daily exercises.
Exercises. There was a woman, actually it might have been a mother, slapping a child.
Daily exercise.
All the phases of that.
So it's fascinating because it's not only from a technical point of view how he did it and how he captured all that motion also from a social historical background. It's amazing.
Yeah, and I feel like that conveys a big point that, like, not only can we get sort of these quantitative, like we think of joint angles and things that we can, get out of these of this video capture method, but we can also capture emotion, which I think a lot of our human motion is actually conveying a lot of emotion. So that case right there.
Yeah, and if you look at more recent experiments in universities, you will see that the capturing motion together with emotions is something that is of interest in relation to pain, for instance. And it's not that they did it on purpose, but if you look at these more recent experiments, you can actually find all the beginnings in here. It's nice.
Yeah, even with mental health too, like looking at how if you have depression, how that might affect how you move and things like that. So yeah, there's definitely that connection that's building. Our facts, I don't know if you have any additional
history.
No, I think we're done, right?
It all stops here. No, of course there's. Yeah, I'm not sure if we can reprint them in the video. Maybe if we give the references, but we can put some photographs in the video if we're allowed to. So yeah, for sure.
Yeah, but I think if we put the source in it, it should be no problem.
Yeah.
So ours will be a little bit more brief, but we are also looking at a bit of a history. I was looking at what kind of the beginnings of muscle contraction, and Descartes from 1646, he thought that actually spirits entered the brain, and then they traveled through the nerves and were basically had the power to change the shape of the muscles, which is how we generated movement. And so these spirits entered the nerves, and then they determined which muscles they wanted to move, and then the spirits would pass through the muscles, and that would make them change shape, and you'd have movement.
Did they already, was electricity invented by then, or was it not invented, but was it investigated, and was it known by that point of time?
I'm trying to, there was
not 1600.
There was a point in time where someone shocked a frog's muscle, and that was kind of the turning point for when they realized that muscles would move with stimulation. And then somebody else also discovered that muscles maintain the same volume when they're contracted. Mm-hmm. So those two findings together kind of form more of like what we know now about muscle contraction.
Yeah.
But I don't remember when that was.
I would think that, I don't think they had electricity in 1646, which is where Descartes is placed in history, at least according to our timeline. Yeah, I don't think, like, because I'm thinking of even like Benjamin Franklin, all those experiments with electricity, at least in the U.S., I guess were much later. But
if you replace the spirits with electricity, it's actually, we are there.
No, exactly. They weren't far off. And somehow they knew about nerves, so.
Right.
Well, going back even farther, if you look at Hippocrates in like 500 BC, he actually suggested that there were sort of these humors that are like the vital bodily fluids, like what is now blood and different fluids that are in our body. He also had yellow bile, phlegm, and black bile. Black bile was like responsible for a lot of diseases and sicknesses. And that these are the things that make up our constitution, like as humans, and also lead to our pain or our good health. So it's interesting that in health, he believed that all of these different fluids were in their correct proportions, but it was when these got out of balance that disease ensued. So it's interesting that that's not completely wrong either, right? Like if we have deficiencies in certain nutrients or certain levels of things, like now we have different, very quantitative tests, right, to measure those different levels. So not far off either. But
yeah. It seems that everything started quite holistic, from a very holistic point of view, and it got very into the details, especially in the 20th century. And now we are back at becoming more very knowledgeable on the very details, but we are also looking at the larger picture again, is my feeling.
It seems like we're coming back. Yeah.
To treating the whole person. Mm-hmm. Yeah. All right, so now we wanted to look at what the definition of biomechanics looks like in the 21st century. So we asked some experts. Who did you guys ask?
Yeah, we asked Professor Wolfgang Potthast from the German Sport University here in Cologne.
Wolfgang is a professor for clinical biomechanics. So he has a strong movement science, movement biomechanics background. So I guess his definition will be a bit towards that direction.
Hi, we are here at the German Sport University at the Institute of Biomechanics and Orthopedics. And we are here with Professor Dr. Wolfgang Potthast. As I know Wolfgang, he will have a nice representation of what biomechanics is. Hi Wolfgang. Christian. I got a short question for you. What is the definition of biomechanics?
Biomechanics is a science dealing with forces acting within and upon a biological system, and also the effect those forces have. Those effects could be accelerations, that means movement of the human body, but also macroscopic and microscopic deformation of the biological tissues. And that leads to adaptations, to positive adaptations or to injuries. And in this wide spectrum of biomechanics, we're dealing with questions of motor control or neuronal control. We call that neuromechanics. Then we're dealing with questions of the relation between movement and load, so which kind of movement is associated to which kind of loading, and vice versa. That's what I call movement biomechanics. That's where I work in the most. And then we deal with questions how tissue loading and tissue response is related. So which kind of movement of the tissue leads to which kind of adaptation in the tissue. That's what I call tissue biomechanics or mechanobiology. And this all integrates different expertises, of course. Know-how in the field of movement science or sports science, in medicine and in biology, but also physics and engineering.
Wow, on the point. Thanks a lot. I should have studied biomechanics with you.
You should have, for sure.
Bye.
Ah, very cool.
Awesome.
Yeah, we interviewed Professor David Camarillo at Stanford, and he's a professor in bioengineering. And his work is more on like soft robotics and designing smart devices that monitor human movement, so more in the medical device realm.
Mm-hmm. Very applications focused.
Mm-hmm.
I'm very excited to hear what he said.
And me too.
We're talking with David Camarillo, who's Associate Professor of Bioengineering at Stanford University. And he designs smart medical devices that monitor human movement. And we're really excited to be chatting with you today, so thank you.
Thank you, David. And so, you've been in the field and around for a while, so we wanted to ask you what your definition of biomechanics is.
So I think of biomechanics as essentially applying theory from the field of mechanics towards biological systems, especially mechanical analysis and design. One point of confusion I sometimes see from students and other groups perhaps as well is what's the difference between biomechanics and biophysics. I think it's a cultural difference more than anything. Biophysicists tend to be educated in physics and then come into biology, and also tend to study more molecular physics rather than, in cellular is maybe where there's a trade-off, but once you get into tissue and organ and whole body, then that becomes more biomechanics, in my opinion.
Very
Makes
cool.
sense. Yeah.
And what made you want to be a biomechanist? What gravitated you towards this field?
I think I've always been fascinated with machines since I was a little kid, and viewing the human body as a machine. I'm very kind of active and used to be an athletic type, and so yeah, viewing the human body as a machine, I've always found is very intriguing, and our mechanics and our movement is really a huge part of being human and what all animals do. And so I thought it's really interesting to apply what I learned as a mechanical engineer in my education to didn't become a bioengineer officially until I was on faculty, and so that's been a really fun combination.
Yeah. Do you feel like it has affected the way that you think of your own movement, or how you?
Oh, certainly.
Yeah.
Yeah, I do. I tend to do a fair amount of research.
I love that
awesome.
term.
Yes, and I'm always thinking of, I got an ankle. I don't do any work in ankle, but I got an ankle problem, and I have lots of ideas of what we could do for ankles or shoulders or necks or right now my work is on brain, and that I had some brain injury, and I had some experience there myself as well. So yeah, I'm always thinking about it, and watching even my kids move and thinking about how to make better training wheels on their bikes and stuff like that. So yeah, it's a fun kind of integrative discipline that way.
Definitely.
It's awesome when it can really become part of your life too, right? I feel like that's where true passions are shown. And one of our other favorite questions to ask people is to share a research fail, to sort of normalize failure in research, because it's, as I'm sure, it's so important. So.
And failure, I think, also depends on how you measure it. So one example comes to mind. We were doing a study. This is a biomechanical research topic. In fact, it was the first project I started when I joined Stanford. I had a student who was working on the biomechanics of eggs and embryos. And the good news, so just a lesson perhaps for your students out there is, even the beauty of academia is, even when you have some failures, usually you can pull some successes out of there, because negative results are still publishable and something you can learn from. There's sometimes there's stuff that you can't get out there, but if you keep pushing, you'll eventually get there, and that's a benefit. But we learned, this student, her name was Livia, learned some really interesting stuff in the laboratory about how the mechanics of embryos was kind of the Goldilocks story, not too soft and not too hard. Something in the middle would predict if the embryo was going to be viable, survive, and turn into a child. This was laboratory work. And actually, she published a paper, so this is only, I guess, a pseudo-failure story. She up to this point anyway, she had at the point for graduation, she published a nice paper on it. But then we took it, we were planning on starting a company on it, and we were getting raring to go. And it ended up staying in the university longer, and we did a clinical study in the university, and we were out there talking to venture capitalists and doing all that. And the clinical study failed. It didn't prove out into predicting live births. So that was frustrating, but at least some of the parts leading up to it were good successes for her. She still published it. And I guess one of the things learned from that, if I always ask my students what are lessons learned, it's okay to fail, just what are you going to learn from it, was test things early, and particularly for academic types, if you have a translational project, the further you can test it out in the lab before you go out and lose real amounts of money is a good thing to do.
Yeah, definitely. Thank you. That's a really good insights from that. And I think sometimes you're worried that it's going to fail, so you almost hesitate to do those testings, but like you said, failing faster and testing earlier is super important.
I mean, even as I remember feeling those same emotions as a PhD student myself. Is this the right direction? I don't know. And just asking that question slows you down.
Right.
Yeah.
Right. And there's no way not to ask that question. But then part of, assuming your audience, there's a fair number of PhD students, being a successful PhD student is kind of suspending disbelief a little bit and taking some risks. And if you roll the dice enough times, you will graduate. And maybe you'll get lucky. I mean, I've honestly found the most successful students aren't necessarily the smartest, aren't the ones that have the best ideas. I mean, that all that stuff helps. But it's those who keep trying. Keep trying and just have some faith. I don't know where they get it from, because I wasn't a student like that. I was more self-conscious, but that it'll eventually get there.
Yeah. Well, I think just hearing that advice and is helpful for us to build that confidence. So really appreciate it.
Good.
What are you most excited about for the future of biomechanics?
Well, you know, I don't know who's doing anything, but like I said, I've got to get this ankle fixed. I've got to get this shoulder fixed. You know, one area, and this is not an area I'm involved in, but it is partly due to my kind of personal interests here, personal emphasized, is tissue engineering, especially in cartilage. I mean, that's a really difficult area because it's not vascularized, because of the mechanical environment, that the loading, and it's a huge need. I mean, you know, quality of life is arguably, people understand that as more important than the length of your life. And, you know, arthritis is a big deal. And again, this has nothing to do with my research yet, but now that I've recently got tenure, maybe I'll switch gears.
Do whatever you want.
But I would be really, I mean, there's all kinds of other tissue engineering, but I've thought more about cartilage and what a challenge that is. And so that's a really exciting area. We've got some folks here at Stanford working on that.
Yeah, that would be really impactful to make some strides in that field, definitely.
Yeah, and good for us as we age. You know?
I'll get there.
Awesome. Well, thank you.
Thanks for talking to us.
Thanks a lot.
So what do you think is the future of biomechanics?
Yeah, well, I think what I'm most excited about is being able to do experiments outside of the lab and in sort of the wild, and also in getting more insights into human behavior and how that plays into our motion, sort of like we were talking about earlier.
I'm also excited for out-of-the-lab applications, and I also am really interested about kind of the mind-body connection, how what we're thinking affects how we move, and then also how we move affects our psychology. So I'm excited to see some advancements in that area. What about you guys?
Yeah, I think that we're very precise with measurements by now. We are very into the details with all the measurements, and what I foresee coming is that deep learning and artificial intelligence will help us analyzing movement. It is already helping, and it will be even more in the future. I don't think we have to measure every bit and piece to the very last detail. Artificial intelligence will help us to understand things even if we don't fully measure them anymore. And it will be good. I'm very sure about that. I've seen a markerless tracking engine last week that incorporates artificial intelligence, and it's amazing. It's really amazing. It's so precise.
Yeah, and I really like you mentioned it, the markerless options right now, because something I do not really like is all this preparation before every measurement. So markerless will be great in the future. So
it will take us into the field as well.
Yeah.
I think machine learning and AI and markerless motion capture are going to be intertwined, and it's a cool future ahead. It's exciting, and looking forward to continuing in biomechanics. And it's awesome that we're able to talk about it and share it with other people, because I think the more people that are involved and bridge it with other fields, the more amazing applications and discoveries we'll make.
Yeah, and we've even had non-biomechanists engage with our content, as I'm sure you guys have as well. Like having a channel, I think, on YouTube makes it so accessible. So it's really amazing work that you guys are doing, and we're so happy to get to be collaborating with you and getting to meet you and learn more and be friends with people all the way across the ocean.
I guess we will meet at the 21 Stockholm conference latest. Yeah, for sure. Yeah, let's do another episode together.